I want to begin today's lesson with just reviewing how to graph equations. This is something that we're probably all familiar with, but just in case I want to go over it again. We've got the positive 3, so I want to go up 1, 2, 3. And then a slope of positive 2 tells me to go up 2 over 1, up 2 and over 1 in the positive direction. And I can go down 2 and over 1, and there's my line. So how does that differ from the equation below, 2x minus 3? Well, we start, instead of at positive 3, we start on the y-axis here at negative 3, and then we still have a positive slope, so our line's going in the same direction. If we were to overlap these graphs, we would be able to see that these lines are parallel. They have the same slope, just different y-intercepts. So over here, the only difference is, this has a positive 3, but now it has a negative slope. So I go down 2 and over 1 in this direction, or up 2 and over 1. Either way, I get the same thing. Or it's the same rate of change, it's just in the opposite direction. Okay, so over here, I start off at negative 3. Once again, my slope's negative, so I'm going up 2 over 1. We want it to be going down as I read my graph, left to right. So, there's the review of that. Now let's look at how we would graph this equation then. So the only difference is that I have an inequality symbol. So instead of saying that y is equal to that, we're saying we're looking for all the values of y that are less than the 2x plus 3. So once again, I'm going to start off with the 3, go up 2 over 1, up 2 over 1, down 2 over 1 in the opposite direction. And because it's not equal to, I don't want to include the points on this line. It's not equal to the points on this line. So I'm going to put a dashed line. Remember back when we were doing inequalities before, we said, like if it was x is greater than 2, when I plotted that on the number line, I used an open circle. There was less to the sign, so there was less to my circle. Whereas if I did x was greater than or equal to 2, when I graphed it, I did a closed circle on the 2 and did all the numbers greater. So it's still kind of the same concept. This was showing that I was including the 2, the closed circle. This open circle showed that I'm not including 2, but I'm starting at 2. So it's the same concept with the line. I don't want a solid line because it's not equal to my line, but it's a starting place. I want all the y's that are less than this line. So I'm going to look here at the y-axis, and I just kind of focus in on one point. All of the y's below this line would be all the values of y that are less than that. So I'm going to shade this side of my line. All of these points over here are possibilities. And a way that we can check this is just pick out any ordered pair over here in the shading. So that would be over 2, up 1, 2, positive 1. So I can plug it in. Is 1 less than 2 times 2 plus 3? Well, 2 times 2 is 4, plus 3 is 7. Is 1 less than 7? Yes, it's true. So I must have done it correctly. Same thing on this line. I want to start off at a positive 3. My slope tells me to go down 2 over 1, down 2 over 1, down 2 over 1. Tells me to go up 2 and over 1 in this direction so that I have a negative slope. Once again, it's not equal to. It's just y is less than. So I'm going to do a dashed line to show that I'm not including the line. I don't want any of the points on my line, but I want to make sure that I know that's where the line is. So I put a dashed line through it, and we want all the values of y, so I'm focusing in on this point, all the values of y less than. So that's going to be everything on this side of my line. And go ahead and try it. Pick out a couple points on this side of the line, the ordered pairs, plug them in and see if it's true. Also pick out a point over here on this side, plug it in, and you'll see that it's not true. Okay, so we can go ahead and look at this one. This time we want all the y's greater than 2x plus 3. So once again, we're not including the points on the line. So we want what kind of a line? We want a hyphenated line or a dashed line. We don't want a solid line. So actually I could probably just leave the points and not even do that, and that would be good enough. But this time we want all the values of y that are greater than. So looking at this, everything above here would be greater than this one. So we're going to be shading on this side of our line. You can pick a point out and test it, and it will be true. If you pick out the point 0, 0, it should not be true. Is 0 greater than 2 times 0 plus 3? Is 0 greater than 3? No. So that's why we didn't want to shade this side over here. We had to shade this side over here because it's the side that is true. Okay, and then it's the same process with this bottom one. Start out at the positive 3. I want to go down 2 over 1, down 2 over 1. You get the idea. Up 2 over 1 this way. And we're going to put in our dashed line. And we want the values of y that are greater than this. So I just always look at my point on the y-axis, and I want the values that would be greater than it. So that would be everything. Oops, my bad. That would be everything on this side of the equation. Or this side of the line, I mean. Once again, you can pick out one of those points, plug it in and check. Or you can pick out one of the points on the opposite side and check. Is 0 greater than 0 plus 3? Nope, so that's why we didn't want to shade the side that included 0, 0. We shaded the opposite side. So I should have showed this at the beginning, but this lesson is all about linear inequalities. It's standard AREI.12, which is to graph the solutions to a linear inequality. That's why we're looking at inequalities today in 2 variables as a half plane. The objective is to graph linear inequalities in 2 variables. We've got the x and the y variable. And we want to ask ourselves, what are we looking for when we graph a system of equations? What do you think we're looking for then if we graph a system of inequalities? So when we're graphing a system of equations, we're looking for the point where the 2 lines intersect. What x and y value is true for both equations? So when there's inequalities, we're still looking for the point that is true for both, but this time with inequalities, we know that there's going to be a whole lot more points. Because if you're saying you just want a value greater, if I say, I want x to be equal to 1, then obviously there's only one answer. But if I say x is greater than 1, well then x could be 2, it could be 3, it could be 4, it could be 5, it could be infinitely many different numbers. Because we're going for anything that's bigger than x. So how are they different? Well, first of all, let's talk about how they're the same. How they're the same is we still have to graph both lines. We still are looking for solutions that work for both equations or inequalities. But how they're different is with the inequality, we're going to have to shade. We're going to be looking for more than one solution. Okay, so is the ordered pair 1, 2 a solution of y is greater than x minus 3? Well, let's plug it in and see. Plug in my 2 in place of my y. Plug in my 1. Is 2 greater than negative 2? Yes, it is. So we know this ordered pair, 1, 2, is a solution. Is the ordered pair negative 3, negative 7 a solution? So let's plug it in. Is negative 7 greater than negative 3, take away 3? Is negative 7 greater than negative 6? That's a little bit tricky because you see the 7, you know 7's bigger than 6, but since they have those negatives in there, that changes it. Negative 7 is smaller than negative 6, so this is not true. Not a solution. Okay. I'm not going to graph this again. I'm going to skip ahead a little bit here to this problem. Actually, no, I want to go back and look at what is the graph of y is greater than or equal to 2. So we go to the 2. If it was just y equals 2, we know it would be a solid line, right, through here. Y equals 2. Does it matter if x is 1, y is still 2. If x is 2, y is still 2. If x is negative 2, y is still 2. So that's why it's a solid line. And notice it's saying that it's greater than or equal to. So it could be any point on this line or anything greater. All the values above this are greater. So that's why we would shade above. Let's look at x is greater than -1. So here's -1, x is -1. So it doesn't matter if y is 1, x is still -1. So we've got all of these points on this line that are true. But notice I'm not drawing a line, I'm just doing the dots. Why am I not doing a line? Because it does not say that it's equal to. It's saying I want to show all the values of x that are greater than -1. So all of the numbers on this side of my line are greater than -1. Okay, so let's try the real world problem here. So an interior decorator is going to remodel a kitchen. The wall above the stove and the counter is going to be redone. The owners can spend no more than $420. So it'd be nice if they spent less, right? We know they want no more than $420. So $420 is the most that they can have, or it could be exactly $420, but it can't be the amount of money that they spend over here on that cannot be more than the $420. So write an inequality and graph the solutions. What are 3 possible prices for the wallpaper and tile? So now let's think about this and let's devise a plan. We don't know how much they're going to spend on the tiled area, so we'll just say that the tiled area represents X. How much they're going to spend on it is X dollars. The papered area, we don't know how much they're going to spend on it, so it's Y dollars. So we know that however much they spend on tiled area plus however much they spend on the papered area cannot be more than $420. So if we want to graph this, we got a little bit of a problem. The problem is that we do not have y by itself. So I'm going to subtract x from both sides. So I have -x and a positive 420 is greater than or equal to y. Now this is in slope-intercept form. Right? We've got our slope is -1, our y-intercept is 420. So obviously I'm not going to want to count up by ones on my graph. We should probably count up by, what do you want to do, 50? So this would be 50. I'll do every other one. We'll do 50. So this would be 100. This would be 200. This would be 3. I'm going to pause this so you don't have to watch me. Okay, and I went ahead and labeled the x-axis the same. Remember, the x is how much they spend on tile, and the y is how much they spend on wallpaper. So they could spend $0 on tile and do all wallpaper, technically, right? And that would give them $0 in tile, and that would be $420 then on paper. Another thing they could do is they could spend $0 on the wallpaper and spend $420 on tile, so that would be represented by this point here. So let's think about some other options they have. Let's say they spend $100 on the tile. The tile is X, so -100 plus 420 would be 320. So if we're at 100, we would go up here to 320. I'm estimating here. If they spent 200 on tile, then they could spend $220 on wallpaper, right? So there's that. And if they spent 300, then they would have $120 to spend on tile. So there's our line. We want to make it a solid line because they could spend these amounts, but they could also spend less. They don't have to spend all $420. So technically they could spend 0 on tile and 0 on paper. They're not going to get very far, but that is a possibility. Then you'd have 0 is less than 420. That would work. So however you do it, it comes out correct. You don't want to do anything in this area over here because those points aren't going to be true. That's going to be over the $420 that they have budgeted to spend on this project. So what I would like for you to do now is think about what happens when we graph two equations. This will be our last problem. This is getting to be a long video. So I want to look at graphing y is less than 2x plus 2. So my slope is up 2 over 1. And do I want to make a solid line or a dashed line? Hopefully you answered dashed. That is correct, because I'm not including the points on this line. Okay, so now let's think about this. I want to shade all of the values above, nope, not above, below the line, because I want the values of y that are smaller than this. They're less than. So I'm going to shade everything that's below this line. Now, I'm going to do a little bit better job on my shading, because now I'm graphing two equations, whereas so far we've only looked at graphing one. So if I'm graphing two now, I am going to have to use different colors so we can differentiate between the two lines here. So now I want to graph this one in blue. -3, 1, 2, 3, and my slope is -1 over 1. And do I want to do a dashed or a solid line this time? Hopefully you answered a solid line. I do want a solid line because we can include the points on the line, because it says we want the y's that are equal to -3, negative x minus 3, or greater than. So if I'm looking here, what value of y is bigger than that? Well, it would be the one above it. So we're going to shade everything above this line. So now what we have to do is ask ourselves what area was shaded twice, because the areas that were shaded twice are the areas that are true for both equations. So if you notice right here, from this line down through here, all of this area was shaded twice. So this green area that I'm shading, all of the ordered pairs in here are solutions to both of those inequalities written up there. I could plug in any of these ordered pairs. I'm just going to pick 0, 0, because that's easy. And that's going to be, should be true for this one and this one. So is 0 less than 2 times 0 plus 2? Well, that would be, is 0 less than 2? Yep. Let's look on the bottom one. Is 0 greater than -0 minus 3? Well, that's just -3. Is 0 greater than -3? Yes, it is. So we can see that that is true. If I was to pick a point out here, it would be true for the blue inequality, but it wouldn't be true for the red one. If I was to pick a point, so only the ordered pairs from the green area are true for both inequalities.